Hello guys, in this video I am going to explain the psychrometric processes. Psychrometry is the branch of science that deals with the study of air and its properties such as temperature, specific humidity, specific enthalpy, vapor pressure, um, specific volume, etc. All these are studied in the subject psychrometry. So psychrometry helps in designing HVAC system. It tells the condition and volume of the air necessary to meet the cooling or heating requirement of a building. Here the condition means the temperature and the other parameters or properties of the air such as relative humidity or specific humidity. Mostly we talk about relative humidity. So all these will be studied in this slide. Learning goal of this video. In this lesson, we will learn the following processes, just as sensible heating, sensible cooling, latent heating, latent cooling, and adiabatic humidification, adiabatic dehumidification, cooling and dehumidification, in the last heating and humidification. All these processes are we introduced in this slide in this video. Some of the process might be covered in our next video. We will try to complete all this. Reasons to learn psychrometry. Why do we learn psychrometry at all? Why it matters in HVAC design? So the thing is, it helps in the assessment of the condition of the indoor and outdoor air. It is very important to know the conditions of indoor and outdoor air before designing the HVAC system. It gives the best approximate of airflow needed to meet the sensible and latent heat load of a building. Suppose we have find out the heat load of the building, then we have to find out how much air and at what temperature should we supply so that it meets the required heat load of the building. It helps in designing the size of HVAC system. It helps in deciding the size of HVAC equipment, such as capacity of cooling coil and its temperature. And the temperature of the cooling coil is also known as the apparatus dew point, also, or in short, ADP. It also gives the best approximation of temperature and relative humidity of the supply air to meet the total load of a zone or a space. So all this is very important in designing HVAC system. So this is very critical to this becomes very critical to study the psychrometry to become a successful HVAC designer. Uh, because there is initial investment and the ongoing bills of energy bills of the system, right? So a right size equipment is very necessary in the design field, because if we adopt oversized system, it will consume more energy and more power, and its initial cost will be more. So it will waste energy and waste money. If the system is undersized, then it will not meet the heat load of the building. So it is very important to find out the actual requirement of the building and then select the equipment accordingly to save the energy and the electricity bills. Frequent use terms. So first is dry bulb temperature. It is the temperature recorded by a thermometer when its bulb is not affected by the moisture present in the air. Okay, and the second one is the wet bulb temperature, T underscore W. So TW is the wet bulb temperature when the bulb of the thermometer is affected by the moisture, is then its recording will be like wet bulb temperature. Generally, a wet cloth or wet cotton is uh, draped over the bulb, and then its temperature of the air inside a room is recorded. So it is called the wet bulb temperature. Humidity ratio, it is the ratio of the mass of water vapor present per kilogram of the air sample. Its SI unit is kilojoule, kilogram per kilogram of dry air. And dew point temperature. Dew point temperature is the temperature when the moisture present in the air starts to condense. Suppose we have a sample of air where we are decreasing the temperature of the air. At some point, there will be some dews or moisture on some solid surface. Then start it will the moisture present in the air will start condensing, and this temperature is known as the dew point temperature. In other terms, we can also say that it is the saturation temperature of the partial vapor pressure at partial vapor pressure. Okay, so if we are taking the partial vapor pressure PV, vapor pressure present in the air Vp, and at that vapor pressure the saturation temperature is known as the dew point temperature. Now frequently used terms again. So relative humidity is next. It is the ratio of the mass of water vapor present in the sample of dry air to the mass of water vapor present in the same volume of air when it is saturated. Suppose we have taken a sample of air, right, and there will be some amount of moisture present in the air. When this air sample is saturated, some more moisture is added to the uh, air sample. uh, at some point there will be no we cannot add more moisture to it when it is saturated. Then the amount of water vapor present in the air when it is saturated, uh, okay, so the ratio of mass of water vapor initially to the mass of water vapor when it is saturated, the same volume, is known as the relative humidity. Sensible heating, it is the psychrometric process in which air is heated in such a way that its humidity ratio does not change. It means W does not change. It's heating of air at constant humidity ratio. Okay, so it will be a horizontal line on the psychrometric chart. Sensible cooling. Sensible cooling is opposite to the sensible heating. So it is the cooling of air at constant humidity ratio. In other words, when the air is cooled in such a way that its humidity ratio is kept constant is known as sensible cooling. Latent and heating and latent cooling. So these are the processes in which the dry bulb temperature is remains constant. We add some moisture, and due to the addition or removal of moisture, its wet bulb temperature increases or decreases. So it is called the latent heating or latent cooling. Now, important formulas. To learn psychrometry or to solve the problem related to psychrometry, we must know some basic formulas. So first of all, how to find the humidity ratio W. So we can generally have some calculator or chart available, but the formula is important. We can learn it. The formula is W equal to 0.622 PV divided by the quantity PV minus PV. Here PV is the partial pressure or vapor pressure of water vapor, and PV is the atmospheric pressure, and the unit is kilogram per kilogram dry air. And relative humidity is as I have said earlier, it is the ratio of mass of water vapor to the mass of uh, water vapor when the air is saturated, MV over Fs. Okay, or we can say PV over PS. Next is vapor pressure. Vapor pressure PV, sometimes we have the wet bulb temperature and atmospheric pressure. Dry bulb temperature is there. Then if using this formula we can find out the vapor pressure PV, okay, or partial vapor pressure PV. Uh, enthalpy. Enthalpy can be found using formula 1.022 TW plus W times the quantity HFGdP plus 2.3 TdP. This TdP is the dew point temperature, and HFDP is the HFGdP is the enthalpy of vaporization. W is the humidity and TD is the dry bulb temperature. If we have these quantities in hand, then using this formula we can find out the enthalpy of the air at that stage. Although these formula are not needed Because we have psychrometric chart or psychrometric calculator. Here we put two parameters like relative humidity and derived temperature. Then the other parameters can be find out very easily. So generally these formulas are not used, but as a basics we should know it, these formulas. Sensible heating. Sensible heating, you can see it is a horizontal line. Sensible heating where this vertical line represents the humidity ratio or specific humidity. So specific humidity remains constant from temperature T1 to temperature T2. You can see the specific humidity remains constant, and so it is called sensible heating. And suppose we have the air flow rate is 100 cubic meter per minute, and outdoor temperature is 5 degrees Celsius. Indoor temperature is 18 degrees Celsius. What should be the minimum capacity of heating coil to achieve the heating of the air? So minimum heating capacity of the heating coil will be 0.2044 VT2 minus T1. We plug in the value, we have V equal to 100 cubic meter per minute, and T2 is 18 degrees Celsius final temperature, and T1 is the initial temperature 5 degrees Celsius. We substitute the value and find out that 26.57 kilowatt is the minimum required, because if the indoor temperature is 18 degrees Celsius, we have to supply the air a little above than 18 degrees Celsius, like 22 degrees Celsius, not 18 degrees Celsius. This is the minimum capacity required. So roughly capacity would be around 30 kilowatt. And this sensible heat also can be found out using the psychrometric chart or calculator, and this gives the more accurate value than the formula given earlier. So a more accurate method for sensible heat load is this. Here sensible heat is V flow rate or divided by the vapor pressure, you can say specific volume Vs, and multiplied by the difference in the enthalpy. Here H2 and H1 can be found out from the psychrometric calculator by putting two parameters like dry bulb temperature and the relative humidity. But to specify the state on the psychrometric chart, we need other parameters such as specific humidity, relative humidity, or wet bulb temperature besides the dry bulb temperature. Let in our previous example, the initial state of the outside air is 5 degrees Celsius, and relative humidity is 55% RH, and the air is heated sensibly to 18 degrees Celsius. Then the solution to the previous example becomes like this. Using the psychrometric chart, we find out the values of H1 and H2. W1 is equal to 0.03 kilogram per kilogram dryer. H1 is 12.457 kilojoule per kilogram. Specific volume V1 0.792 meter cube per kilogram. The inside air conditions can be found using the dry bulb temperature and the specific humidity W1. Okay, so at this point 1, we are given the values. Okay, this value, if we have dew point derived temperature, and we have no W1 here, so W2 is equal to W1, and using TD2 and W2 we can find out the other values here like this. 0.03 kilogram per dryer, and H2 is 25.6955. So sensibility will be equal to V times H2 minus H1 divided by V as specific value. Plug in the values, we come out with 27.86 kilowatt. This is more accurate result. Sensible cooling. So the process is like from higher temperature to lower temperature. This is temperature scale, this is the specific humidity scale. So temperature is decreasing, so it is called the sensible cooling. If we talk about this, the formula will be the almost same. 0.02044 V T2 minus T1 minus T2, where V is the meter cube per minute. Okay, so it is the meter cube per minute airflow rate, and T1 T2 temperatures are in degrees Celsius, or we can say V H1 minus H2 divided by 60 V, where V is the airflow rate in cubic meter per minute. We can use this formula or this formula. There are two formulas to calculate this. So let the outside air is 35 degrees Celsius and 55% relative humidity, and inside condition is kept at 22 degrees Celsius. If the airflow rate is 60 meter cube per minute, find the sensible heat load. So SH is like 0.02044 times 60, 35 minus 22. So it comes out to be 15.94 kilowatt. The more accurate value can be found using the specific enthalpies. You can do it by yourself. Now next is latent heating. Latent heating or addition of moisture at constant dry bulb temperature. It is the process in which the dry bulb temperature remains constant. The heat is added to the system on account of the addition of moisture. The dry bulb temperature remains the constant, but wet bulb temperature is raised. The process is shown by a vertical line on the psychrometric chart. Latent heat. It is the amount of heat added or removed due to the addition or removal of the moisture to a sample of air. It is denoted by the letter QL, LH or QL. Okay. And if the moisture is added to the air such that its initial and final specific humidity are W1 and W2, then the specific enthalpies of the state 1 and state 2 are H1 and H2 respectively. If the mass of the air is then latent heat LH and added Q1 is equal to 50 V times V, the quantity W2 minus W1. So latent heat equals mass times H2 minus H1 also. There are two formulas for this. One is 50V W2 minus W1, other is mass times H2 minus H1. And mass is nothing but the air flow divided by the specific volume. Amount of moisture added also can be calculated like MW, M sub W equal to mass of air's flow rate times the change in specific humidity. We can find out using this formula the mass of water added or removed, and using these two formulas, either of these one, we can find out the latent heat added. Latent heating or addition of moisture at constant dry bulb temperature. Again, we can have some example here. So moisture is added to an air stream at 25 dBT and 50% relative humidity such that dBT of the air stream remains constant. If the airflow rate of stream is 50 cubic meter per minute, final condition of the air is 25 dBT and 80% relative. Find the latent heat added to the stream. So here we have W1, W2 is given, and at dry bulb temperature we will apply the formula 50 V W2 minus W1. This will give the approximate value. Okay, and so V is given here. V is 50 meter cube per minute here, and W1, W2 can be found using the psychrometric calculator or psychrometric chart. Okay, so using the table or chart, we find the at 25 dry bulb temperature and 50% relative humidity, W1 comes out to be 0.0099 kilogram per kilogram dry air, and at temperature 25 degrees dBT and the 50% relative humidity, 80% relative humidity, not 50%, W2 comes out to be 0.016 kilogram per kilogram dry air, and the specific volume is 0.856 meter cube per kilogram. Using these values, we can find the latent heat added. Latent heat added like 50 times 50, 0.016 minus 0.0099 kilowatt. That is 15.25 kilowatt. And amount of water added also can be found here. Mass of air supply will be volume flow rate divided by the specific volume. So it will be 50 divided by 0.856 and times the 0.016 minus 0.0099. So 0.356 kilogram per minute. And it comes out to be 21.378 kilogram per hour. Latent cooling is the reverse process in which also we can find out the value W1 and W2 here, and mass of air flow also can be found using the volume flow rate divided by the specific volume, and then we can find out the amount of water removed from the air. This is very important also because it tells us the size of the drain pipe. If the more water is condensing, then we need more bigger pipe. If the little water is condensing or removing from the air, then we need the smaller pipe, drain pipe generally. Cooling and dehumidification process, in this process you can say the humidity ratio decreases, specific humidity decreases, and the temperature is also decreases. So process goes in this direction. Heating and dehumidification means humidity, heating and humidification, not dehumidification, means the humidity increases and the temperature is also increases. So it's positive slope and vertically going up the line. So this is the slides present, and I will cover all these in our next video, and I will also give the some example related to it. Please like and subscribe this video, and thank you for watching.